Hello everyone. A very good evening to all of you present here. I am Prajakta and on behalf of Girl Up Ehsas, I take this pleasure to welcome you all to the session of AIML Venture, a complete pathway to artificial intelligence and machine learning. Girl Up ignites the empowerment of girls by girls around the world. We at Girl Up Ehsas focus on uplifting the weaker section, that is, the females of the society, and training them to be able to compete with the other sections of the society. In partnership with the United Nations, we stand up for girls, speak up for programs, and help them thrive and rise up as a community of advocates to change the world for good. Before starting with the event, I would like to inform you that we have a picture quiz for you, and my teammates Dhairya and Drishika will explain you all the rules. So I invite Dhairya and Drishika to please start with the picture quiz.
Thanks, Projekta, for giving us the stage. So, me and Drishika will be organizing a Pictionary today on basic questions of AI. The importance of these quizzes are that it tests the memory of any individual by giving them a practice to remember for a long time. So, before starting, there are some few instructions for the quiz. So the first instruction is that you will be shown a picture on the screen and you will have to write your answer in the chat box. Second, you are not allowed to answer more than once, means that you have to write your answer for first only one time. Third, each picture will be shown for 10 seconds. Fourth, you will be given 5 seconds to answer after that. If you write your answer while showing the picture, your answer will not be counted. Fourth, you will have to take the screenshot of your YouTube username while answering. Last, results by the organizing team will be the final. So I would like to hand over the mic to Drishika for starting the quiz.
Thank you, Dhari, for explaining all the instructions. So, hey everyone, Drishika here. I hope you all are clear with the instructions. So, without any further delay, let's get started with the quiz. All the best, all of you. And here comes the first question. A picture is being displayed on the screen, and you need to guess whose picture is this. And please don't start giving answers right now. You need to give the answer after when I shift to the next slide. Now you have 5 seconds to answer, so hurry up. Time's up, guys. And the answer is PyCharm. PyCharm is the most popular IDE for Python and includes great features such as excellent code completion and inspection with advanced debugger and support for web programming and various frameworks. Moving on to the next question. Again, you need to guess the logo which is being displayed on the screen. Now you have 5 seconds to answer, so hurry up. Well, this is the easiest of all, so I really hope you all might have answered correctly. And the answer is Python. Python is a widely used general purpose high level programming language. Python allows programming in object oriented and procedural paradigms. Now, the next question is, can you guess who is he? Now, you have 5 seconds to answer, so hurry up. Time is up, guys, and the answer is Guido van Rossum. He is a noted Dutch computer programmer and author, better known for creating the Python programming language that earned him the title of Benevolent Dictator for Life. Now, the next question is, you need to guess the logo which is being displayed on the screen. Now you can start typing your answers in the comment section. You just have 5 seconds, so hurry up. So the correct answer is Microsoft Azure. It is a a computer platform designed by Microsoft to successfully build, deploy, and manage applications and services through a global network of data centers. And the next question is, you need to guess the logo which is being displayed on the screen again. You have 5 seconds to answer, so start typing your answers. And the answer is TensorFlow. It is an open source end to end platform for creating machine learning applications. It is a symbolic math library that uses data flow and differentiable programming to perform various tasks focused on training and inference of deep neural networks. It allows developers to create machine learning applications using various tools, libraries, and community resources. Moving on to the next question, you need to guess the name of the robot which is being displayed on the screen. And I really hope most of you might be knowing the answer for this because this is a very famous robot. You can start typing your answers in the chat box. And the answer is Sophia robot. Sophia is a human-like robot. Sophia was developed by Hong Kong-based company Hanson Robotics. The AI robot has been designed to learn and adapt to human behavior and work with humans. Moving on to the next question. You need to guess the name of the robot which is being displayed on the screen. Well, this question was new for me as well, so I don't know how many of you might be answering this, but let's see. Now you can start typing your answers in the chat box. Time is over, guys. So the answer is a mini cheetah. MIT's new mini cheetah robot is springy and light on its feet with a range of motion that rivals a champion's gymnast. The four-leg power pack can bend and swing its legs wide, enabling it to walk either right side up or upside down. Moving on to the next question. You need to guess the logo which is being displayed on the screen. Now you have 5 seconds to answer, so answer fast. And the answer is Tesla. It is an American electric vehicle and clean energy company based on Palo Alto, uh, California. Tesla's current products include electric cars, battery energy storage from home to grid scale, solar panels, and solar roof tiles, as well as other related products and services. Moving on to the next question, you need to guess the icon which is being displayed on the screen. It is also one of the easiest questions, I feel. I personally feel it, but let's see how many of you might be aware of this question. Now you have 5 seconds to answer, so hurry up and answer. Yeah, give your answers in the chat box. And the correct answer is Microsoft Cortana. It is a virtual assistant developed by Microsoft which uses the Bing search engine to perform tasks such as setting reminders and answering questions for the user. Now, moving on to the next question, and this one is the last question. You need to guess the logo which is being displayed on the screen. You can start typing your answers in the chat box now. You just have 5 seconds, so hurry up. And the correct answer is IBM Watson. It is AI for business. Watson helps organizations predict future outcomes, automate complex processes, and optimize employees' time. So thank you everyone. But before leaving, I would like to give a final instruction. Please don't forget to take the screenshot of your YouTube username as it is necessary for the final decision. And now to proceed further with the program, I would like to call upon Prajakta to continue from here.
Okay, so thank you so much, Darya and Trishika, for this wonderful quiz. I hope all our participant friends must have enjoyed it because I have seen like the comment section full of all the responses. So moving ahead with our event, I would like to first introduce what is AI and ML. So Google CEO Sundar Pichai says AI is a core transformative way by which we are rethinking how we are doing everything. AI is probably the most important thing humanity has ever worked on. This is so true. Our intelligence is what makes us human, and AI is an extension of that quality. I am sure you all must be very excited to listen to our today's speakers about what is exactly AI/ML, how does the industry work with these technologies, and their experience and journey in this field of AI and ML. Like, how did they start with all this? So, we have three speakers with us today. I would like to introduce you all with our speaker, Hashim Taha. He has completed biomedical engineering from University of Toronto. He is a co-founder at OncoCellular and currently working for Explain as head of partnerships. Our next speaker will be Mohit Chandra. He has done his BTech from IIT Hyderabad. He is a research assistant at Georgia Institute of Technology and was an intern at Microsoft earlier and currently working as a full-time software engineer at Microsoft. Our third speaker is Aditya Paul. He has been a student researcher at Samsung Strategy and Innovation Center and founder and team leader at Cognitive Applications Research Lab. He's currently a Google AI Explore ML facilitator and helping students around campus who wish to explore ML through this program. I welcome all the speakers for our event today, and without further delay, I hand it over to all of you.
Thank you, Prajakta, for the really lovely introduction. Hi, guys. So, me, Hashim, and Aditya would be talking about our journeys in this field, and we'll be sharing all of our experiences and the present and future of AI. So, without further ado, I would like Hashim to start with the session.
Thank you, Mohit, and thank you for the Girl Up SAS team for having us here. It's truly a pleasure to be speaking to a great audience and to really talk about an exciting topic, which is the transformative potential of AI and the different applications of AI. As the introduction was made, I am the head of partnerships at Explain. What we're doing with Explain is we're building a community where people can build, buy, sell, try, and use AI. And a lot of the things that we have been thinking about is how to really deeply democratize AI and make AI available for everyone. So I like to start sort of conversations around AI with some really cool anecdotes and stories about really how AI, how the term AI came to be and how the whole field has sort of developed and evolved. So, AI was a term that was coined back in the 1950s. I mean, it's really crazy to think that you'd think that AI is something that's happened the last 10 years, given the accelerated adoption and the evolution of the technology. It was a term coined by a professor at Dartmouth, John McCarthy, in the 1950s. And John McCarthy had a sort of a vision, because he had a research agenda to kind of augment or build on what another sort of professor at MIT, Norbert Wiener, developed a field called cybernetics. So cybernetics is Norbert Wiener's vision for intelligent systems. It's a field that combines, statistics, operations research, information control theory. John McCarthy wanted to bring the idea of artificial intelligence as in a system, or develop certain rules and logic to actually give artificial systems, give computers, machines, robots the ability to think and reason and behave like humans. And that really was sort of the first, the birth of AI as a way to put sort of carbon intelligence from humans and transfer it to intelligence in silicon. What became interesting over the years is, under the terminology of John McCarthy, which is artificial intelligence, the intellectual agenda of Norbert Wiener, which is cybernetics, actually ended up being the most relevant, which is how what we think of artificial intelligence and industrial applications of artificial intelligence were really most of the time referring to machine learning. So, the general field of artificial intelligence is, when we talk about, a robot like Sophia, who's actually is a sort of a representation of what we call artificial general intelligence, a robot that can talk, a robot that can think on its feet, a robot that can retrieve information from massive repositories of data. This is, what we call human imitative intelligence. But what's interesting is that machine learning, in the form of a field or an algorithmic field that really gets to understand and process large amounts of data using statistics and computer science and other fields, is what really has is the representation of Norbert Wiener's cybernetics intelligence systems, but really under the banner of John McCarthy's artificial intelligence. And it's even funny because when you think of some of the deep-rooted or some of the most advanced algorithms today, if we take machine learning as a subset of artificial intelligence, one of the most famous types of algorithms developed in machine learning is the backpropagation algorithm that was sort of rediscovered by David Rumelhart in the 1980s. And if you look at the history of innovation, the history of ideas, you would see that backpropagation algorithm actually was used in the 1960s to actually, in the field of control theory, to model or power the thrust in the Apollo space missions. So with that sort of introduction, I mean, what is machine learning? So machine learning is, and I'm not going to bore you with the details. I'll try to make this as general as possible, and I'll spend some time to talk about the trends and the opportunities and what we're seeing in terms of adoption of machine learning. So machine learning is a subset of AI where leverages, as we mentioned, computer science and statistics to actually process streams of data and generate certain outcomes or predictions. The term here is the word inference. Inference really is to infer from a set of existing data of what could sort of future data or the data that you've not seen, how to make certain decisions. An example would be, you notice, for example, certain people clicking on a certain ad online, and you have, for example, hundreds of thousands of people or behavioral patterns of how people are clicking on an ad. Well, how can I actually develop an algorithm or a tool that's basically based on machine learning that can predict somebody who's never clicked on an ad, are they going to click on an ad or not? So obviously, it is not a deterministic, it's not a defined set of rules, actually all probabilistic. With the machine learning system can actually ingest this and give you a system that tells you, if you publish this ad in this particular space or in this particular domain, there is an X% chance that a user of this behavior will click on that ad. And why? Because the system is inferring from past data or previous data something along those lines. It's the same thing, obviously, we see with healthcare. If somebody is presenting with certain symptoms, or somebody is presenting with a certain pattern of cardiovascular activity or vital signs or neural activity, what are the chances that they would be developing stroke or congestive heart failure or something like that? So the types of machine learning problems that we're seeing right now, they could be predictive. So you're doing predictive modeling. You're taking something and you're predicting what could happen in the future. So you're extrapolating. You could be classifying. You could be looking at certain events, and you would be able to classify in clusters. So you'll be able to group certain things or certain activities or certain observations, whether it's digital or whether it's in the real world. And actually make sense of those and be able to provide intelligent decision making, whether it's to policymakers in government or business leaders. And that's really, obviously, the quality of the data determines how good the decisions are. And the motto, or the sort of the common language in the industry goes in like garbage in, garbage out. If you really feed your system bad data, then you cannot expect your machine learning algorithm or your machine learning model. Just for context, I mean, a model is an algorithm or a group of algorithms that has been trained with data, and now that becomes a model. And when you run the model, you actually engage in the process of inference, because now the model is actually inferring from past data. So Mohit, my fellow speakers here, Mohit and Aditya, are more technically sort of poised to speak about the details, but I want to spend a few minutes just to talk about the really exciting applications we're seeing in machine learning. What type of opportunities, how big is the market, how big is sort of the field that we're looking at. So we actually did at Explain, we did our own internal analysis of just looking at what's the sort of the talent size, what's the value of the talent pool. And obviously we just looked at the US market because we had some of the job posting data, and we developed, or the range we came about just by being very conservative. The way we've done it is just a simple model based on the number of AI postings in the US, and having a range of potential income for people doing different degrees of AI, whether they're scientists or engineers. And we came up with a range anyway from $29 to $35 billion. And that's, by the way, that's the gap. That's not the size of the market. That's really how much companies right now are accelerating hiring. So accelerating hiring in AI. And that spans people in data science and ML engineering and ML science. So really, truly an exciting time to be alive. If you're just getting into AI, you're starting to get or develop your portfolio of machine learning projects. This is no short of the industrial revolution, because you're getting into a space where there's a lot of demand and hunger for the types of skill sets that are being developed in AI. So I'll spend just a couple more minutes just to give you an example of what we're looking at, or in the field of AI. You heard me talk about, for example, marketing automation. We've spoken about healthcare applications, whether it's detection of healthcare signals for clinical decision support. So really, there isn't a single industry that's actually not being touched by AI. Whether you're, the simple example of AI is when you see in Amazon what you see in Netflix. The fact that you click on certain things and you get a personalized item on your cart as a recommendation engine, or as a recommended item to buy, that's actually an embodiment of applied AI and ML. In the legal and insurance domain, we see, for example, intelligent document parsing. Think of so one of the things that actually is truly fascinating about applied machine learning is when you think of scalable systems. We're not talking about, I just want to automate the process. Machine learning is not just about the automation. It's about how do you do simultaneous parallel processing of large volumes of data. Think on the orders of 200 million documents or 100,000 documents that you really want to analyze and you want to extract certain information, whether it's for legal discovery or for fraud detection or for compliance management for certain large financial institutions. That's really where the power of machine learning comes, is you're able to process these types of structured and unstructured data, depending on the type of machine learning model you develop. And it's not just, by the way, it's not just text, it's not just documents. I mean, machine learning actually processes signals, whether it's stock market signals or power signals coming from an industrial piece of equipment, or it can actually be processing vision. You know, this video right now, people on AI can look at me and say, hey, is this guy happy to be here, or is he is he not excited to be here? And hopefully, if an AI sees my face, they'll understand I'm very excited to be here. So there's a lot of, emotion detection, facial recognition technologies, and we can go on and on and on. So some of the things we're seeing at Explain, because we're obviously building a market network, we're seeing lots of exciting applications in legal, media, and entertainment. I mean, I was just truly, truly impressed by the number of people coming. Oh, we want to do dubbing. Just imagine like you have a show in the States and you want to actually translate it into Arabic or into Farsi or into Spanish. The idea to actually develop AI end-to-end systems and workflows is actually, you don't think certain problems are AI, but they're truly AI. Just the idea of running a machine translation. I mean, right now, as I'm speaking, there are tools that can automatically transcribe my conversation and just create sort of a script. Imagine me and Aditya and Mohit are having a conversation, and AI can detect Hashem is talking versus Aditya versus Mohit. So automated video production, dubbing, synthetic voices. I could actually be feeding my voice into a model and actually generate a branded voice, where with the quality of the AI over time, you wouldn't know that that's an AI generated voice. You'd almost think that this is actually me speaking. So I guess I hope this was sort of a good overview, just to give you a sense of where I mean, the sort of an introduction to AI and introduction to machine learning, and some of the exciting applications that we are seeing. And I kind of would love to open up to my colleagues, and really happy to be here and excited to be around. Thank you.
Thank you so much, Hashem, for discussing about the various applications of AI. It was really exciting, and I would request Simona to take over for the first part of the discussion.
Sure, thanks, Aditya. Can you just present the slides? Or let me do so.
I think it will
work. I'm sharing my screen. Yeah.
Okay.
Hey guys, so thanks Hashim for that lovely introduction to AI and ML and what are the further scopes in the industry for that. So now since you know about the various opportunities that are available in AI and ML, let's just start with how we can get started with this field, how we can enter this domain. So first, let's start about what are the various subdomains in AI and ML. So Aditya, if you can confirm if everything is working fine.
Yes, everything's
cool. Awesome. So let's just start about what are the different subdomains in AI and ML. We have divided this into 4 major categories. As Hashim already said, there are various other ways in which machine learning is already being applied. But just to keep the around basic fields right now and looking at the time constraint, we just divided it into 4 major fields which have been in practice over a couple of decades. First is natural language processing. The second is computer vision. Third is the application of AI and ML in robotics and multi-agent systems. And fourth is a new field that has come up, which is called AI for social good. We would be explaining each of them in detail in the further slides. Okay, so now since we know about what are the different subdomains, let us just talk about what are the fundamental concepts that you need to know or you need to learn about for entering this field. Remember that there's a lot of APIs that are available out there, but it's always a nice idea to know about some of the fundamental concepts. So we have actually divided into five parts that are pretty much exhaustive in nature of starting with ML. So by learning this concept, not only you will be able to develop your models in a better fashion, but also be able to read really good books which are available out there, and also research papers that are being published recently. So let us just go through these five major concepts briefly. So first is linear algebra. Linear algebra is the go-to thing for everything related to backpropagation, related to tensors, related to neural networks. You need to know about the notations, operations, basic matrix operations like matrix multiplication, matrix addition, etc. You need to know about matrix factorizations, as these are also used widely in NLP as well as computer vision. Secondly, calculus is a strong tool for ML. As some of you might have already heard about the term propagation, which Hashim also talked about, right? So back propagation is nothing but chain rule of calculus. It's as simple as that. And for knowing back propagation, you need to be good with calculus. You need to be good with derivatives. You need to be good with gradients, Jacobian matrix, etc. Probability theory is something that is used widely in Bayesian AI, and we always deal with random variables, distributions, conditional probabilities, and expectation. Probability theory is something that is really essential for doing theoretical research, especially if you are aiming for research in game theory or statistical machine learning. Their probability theory plays a major role. uh, I'm gonna cover the last two in a combined fashion. So statistics, although it is not very related to machine learning, but some of the concepts are being taken from statistics and applied in ML. Certainly, about when you are given unstructured data and you need to derive meaning out of that, then statistics plays a major role. Say, let's for an example, you are given a real data about movie reviews. Now you want to know about what are the basic statistics about it, how much people are how many people are reviewing how many movies, or what is the mean of the age of the people who are reviewing the movies, and certain statistical parameters like that. In that, statistics plays a major role. Sometimes you also need to make some hypothesis tests, because machine learning models, since are predictive in nature, you need to come up with some hypothesis, and those are tested using statistics. Now, the four fundamental concepts that I discussed before were theoretical in nature, right? The fifth one is practical. So once you are well versed with these four subtopics, you need to apply them, right, for building machine learning models. So for that, we feel that Python and R are the go-to libraries these days. And if you don't know about Python, if you are not comfortable with Python, you can easily start with some of the basic courses that are out there on Code Academy, on Udacity, etc. And you need to know about the fundamentals of Python, how arrays work, how list works, how to write a for loop, etc., etc. NumPy pandas are the go-to libraries for machine learning. So if you don't know about them, just go read about them. NumPy and pandas, they are extremely easy to learn. You will find a lot of resources online out there. Vectorization, and then there are two big machine learning and deep learning libraries called TensorFlow and PyTorch. In the quiz, you saw the TensorFlow logo, right? So that is one of the libraries which is developed by Google, and developed and maintained by Google. And then there's PyTorch, which is developed and maintained by Facebook. Both of them has their pros and cons, but you can choose and start with either of them. Both of them are great libraries for building up on scale and doing machine learning based research. So I guess these are some of the starting points where you can build your concepts and also build your resume by using these libraries and building projects out of these. So these were the fundamental concepts. Now I'll ask Aditya to tell us more about the online courses that are out there.
Thank you so much, Mohan. I wholeheartedly agree with the fact that learning these fundamental concepts first would definitely make your life much easier at various stages of time. For example, learning the basics of linear algebra and calculus made it much easier for me when I came to learn more about how backpropagation works, etc. etc. And in the last part of the previous slide, is my voice clear now?
Yeah, yeah,
Alright. And in the last part of the previous slide, we discussed a bit about Python, how it's used often in machine learning, which we see all around us. If you're starting off and you don't know either Python or R, I would probably side towards Python more because it has more ready-made code available, seeing which you can learn about those concepts more easily. Could we go to the previous slide, Mohit?
yeah, sure.
And Mohit already mentioned the libraries like NumPy, Pandas, etc. I would like to add on that for those of you who already know a bit of Python and are trying to speed up your machine learning models, you can definitely look up something called vectorization. So it is something which is already taken care of by NumPy in some of its data structures. But even if it's not, you can definitely try to convert your loops. So whenever we are writing any program, we have to do some operations repeatedly. So when these operations are done on matrices and we are repeatedly moving across the elements of the matrix, that process can be parallelized and made much more faster by a concept called vectorization, which is very interesting. And nowadays we have a lot of applications which leverage applications or say frameworks which do leverage this concept of vectorization. For example, say NumPy, Pandas, or JAX, which is developed and maintained by Google. The second point, one of the points here is JIT compilation, which stands for just-in-time compilation. So that's how the compiler works. So that's how TensorFlow works in the backend, or we have compiled, and we don't have any truly non-compiled languages, but understanding how the compilation works, the graphs are compiled, that would make your understanding much more faster, and that would also make it much more easier to actually debug the various modes. For example, in TensorFlow version 1, we had something called the standard mode, and we could transform into ego mode. The ego mode, I'm sorry, in TensorFlow version 2, it was introduced. Prior, you had to run the session itself. So knowing about these compilation issues would make the process much easier. And nowadays we hear all around us that Google has introduced GPUs and TPUs. So working with them efficiently would require just a few lines of code, and understanding how we can work with such graphics processor, GPU and TPU systems or multiprocessing systems would make your work much easier. Okay, then now I would like to cover the fundamental courses or the courses which primarily I started with, and many across the world have started with. So, of course, one of the most common courses which everyone has pretty much started with is Andrew and Jay's Stanford Machine Learning course. There's also another very popular course which many beginners start with, which is the Fast AI Pathways for Machine Learning. So they have a couple of courses which are as good as the Andrew and Jay's course, I would say. And I would say they delve a little bit more into the technical aspects of things. Now, these courses cover the theoretical concepts of machine learning with some practical implementations. But to be an expert in machine learning that is easily be able to deploy models, etc., I would also recommend that you do any course on TensorFlow or PyTorch fundamentals, which will cover all the aspects of the framework which you will be using every day of your life, assuming you are in a career of machine learning. Data science, that is something which most of us usually learn over time. Personally, I did not do too many courses for that. You can definitely do any Python or R fundamentals course, and then go on and do some courses on data visualization if you want. For example, Tableau is very commonly used for data visualization purposes. We should know a little bit about data wrangling. So how do we clean the data? What sort of columns we do not need? And developing an intuition. This can come through courses, and this will also come at a much larger scale through the number of projects which you are doing. And statistics and machine learning was also mentioned in the fundamentals of machine learning. And these statistics and math-based courses are also going to help advance your career in the world of machine learning. Thirdly, for natural language processing, currently TensorFlow has an NLP specialization, which I found to be quite good. So it's there's also a course 5 in the deep learning.ai specialization, which I believe talks a lot about the RNNs and LSTMs and GRUs and how these are useful for natural language processing all around this. Finally, in computer vision, we have the deep learning.ai specialization. Here I would say that only course 2 or 3 actually focuses on CNNs, but the rest of the course itself would provide a good groundwork on how to get into this field of computer vision. And since I learned a lot from TensorFlow's documentation and the collab notebooks which they have attached as starter notebooks, I would definitely consider them to be at par as a learning resource besides the courses as well. So, without further ado, I
Yeah.
would request Mohit to take over, share his thoughts on these.
Yes, great insight, Aditya. And just adding to that, as Aditya has also already mentioned, knowing fundamentals of ML, knowing the theoretical concepts is all right, but you won't learn about the real challenges that comes with real data and machine learning in general without doing some application based courses. Either you can develop that application based aptitude while doing some projects on your own, but as someone who started with online courses, and Aditya also has taken so many online courses out there, we feel that doing online courses not only helps you build your theoretical concepts but also gives you a opportunity to work on some really exciting cool projects in a limited time frame. So since if you have ever taken any online courses, whether on Coursera, whether on edX or Udacity, etc., you have a definite time frame in which you need to complete that assignment or the project. So that keeps you going, and then the certificate that you get is also a very good reward that you get after completing the courses, which you can obviously showcase on your LinkedIn profile. So that's how you learn about these concepts and also get to improve your resume by adding some of these great projects that they teach. So yeah, now since we know about the theoretical concepts and the online courses that we need to take, let's just jump on to the different subdomains of AI and ML that we earlier talked about. So without a further ado, let's start with natural language processing. In short, NLP. NLP lies at intersection of linguistics, computer science, and artificial intelligence. It is essentially concerned with the interaction between computers and human language, and in particular, how to program computers to process and analyze large amount of natural data. So the first question, which would be, what is natural language data? So anything that we speak, anything that we write, English, Hindi, Tamil, Telugu, any language, you name any language, that is natural data. Now, I'm pretty sure that every one of you have come across some of this, one or the other system which has some NLP component working behind it. And why do I say so? Because you all must have searched something or the other on any of the search engine, say Google or Bing or any other search engine out there. So, what are the applications? Some really cool applications of natural language processing that are out there. So, I'm going to discuss three. One is autocomplete, then we have machine translation, and then we have chatbots. Do keep in mind that these have a lot of complexities going on because these are on scale and on production by big companies like Google, Microsoft, etc. But we can always build a simpler version for us, right, through our projects. So I would be going through these projects in a simpler fashion, which the concepts that you can apply to build your own simple projects on these things. So let's just first talk about autocomplete. So what is autocomplete? While as you can see in the GIF here, while typing on Google, you must have realized that once you type, say, some X amount of words, Google already suggests you the next word that you would be thinking of, possibly be thinking of. So how does Google knows what you might be thinking of? The answer is pretty simple. On backend, the basic technology that is working is something called a language model. Language model is nothing but how we feed a language, how we make a machine learn our language. So, say, suppose I teach a machine about the language English. So now, whenever I type, say, for example, my name is Mohit. So whenever I will type my name is, the machine should be able to guess that, yeah, this person is trying to tell his or her name, and this is his name. So let me just suggest Mohit to him, and if it does, then it's a really good autocomplete or language model. So how do you build your own autocomplete? It is pretty simple. If you know about LSTMs, which is long short term memory, it is a fundamental say structure or algorithm which is used widely in NLP. It is used for predicting the next word. By predicting the next word, I mean, given you have typed or said, say, X amount of words, say 3 words, 4 words, or 5 words, the job of LSTM is to predict the next word that is the most probable word out there. So this is the fundamental of behind autocomplete. Now let's just jump to machine translation. I'm pretty sure that at some point in your life you must have used some sort of machine translator, whether you are traveling, whether you are talking to someone who doesn't know your language, etc. And here I have attached a screenshot from Google Translate, which you all can try out. So it works on a basic principle of sequence to something called sequence to sequence model. These models are used for translating one language from one domain to language of other domain. Now these languages need not to be natural languages, like not like English, Kannada, Hindi, Punjabi, etc. These can be code too. So suppose you can always make a machine translation system which takes your English output, English input, say, how do I code a for loop in Python? And then outputs a code on the other side. So the aim behind sequence to sequence model is to translate the language and words or tokens from one language to the other. And this is the basic fundamental principle behind every machine translation system that is out there. Third is something that is really interesting is chatbots. While chatting with the customer service or filing some complaint or report, you must have come across some or the other chatbots, whether it's Zomato, whether it's Mastercard, whether it's SBI bot, or any big company has chatbots out there. And the idea behind chatbots is that you feed the machine the possible questions and answers that are out there, which can be asked from the machine. And then using the machine learning techniques like active learning and NER detection. NER stands for entity recognition. Using these techniques, how do you come up with the best possible answer to a question that been asked by a human? So this is the simpler basic fundamental that goes behind chatbots. So you can see natural language processing affects our real day-to-day world in a lot of ways. You have seen, and there are many ways in which NLP is applied out there. I have covered just 3 of them. Now, let me just go to the second slide. NLP is also applied a lot in speech systems. So you must, if you have a smartphone, the probability is pretty high that you must have interacted with some or the other digital assistant, whether it's Siri, whether it is Cortana, whether it is, say, Google Assistant. So how do these work? Similarly, if you have a smart speaker, say Alexa or Alexa at your home, the technology behind both of these things is pretty much same, which is based on speech recognition. So let me just define speech recognition in a brief manner, and then probably we can just talk about how these digital assistants and smart speakers work. So, speech recognition is an interdisciplinary subfield of computer science and computational linguistics, which is aimed at enabling the recognition and translation of the spoken language to text by computer. So, in a layman term, it is just that you speak some words, and the aim of the machine is to understand what you are speaking and just translate into text or any form of data which is understandable by the machine. So let me take an example of Apple Siri. So Apple Siri, what it does is that it takes your input in form of speech. You speak, "Hello Siri, can you open contacts for me?" For example, you are asking Siri to open contacts for you. So what it does is that it first transforms your speech data into other domains using Fourier transforms or using some other transformative techniques into a machine understandable form. Then it uses language models and automatic speech recognition models to understand the phonemes. Phonemes is something which is very fundamental to speech system. It is, say, a unit of understanding the speech. And through that, using that machine learning techniques, it understands what you are trying to say, and then it translates it to text or any other digital format that you may be aware of. Similar is the concept behind the smart speakers. So you can see how NLP has truly transformed our day-to-day lives. I'm pretty sure that most of you would have at least interacted with 3 or 4 out of 5 of these things in your day-to-day life. Talking about myself, I interact with all 5 of them on mostly daily basis. So NLP has truly transformed my and millions of other lives and made our lives so much easier. Now I would like Aditya to talk more about computer vision.
Thank you so much, Mohit, for sharing your insights and practical experiences from the field of natural language processing. Computer vision is another field of machine learning which deals more with the visual sensory inputs. These are basically signals in the form of RGB images or hyperspectral domain images. So, what is an RGB image? An RGB image has basically 3 channels. Each channel will have n cross n pixel values. So, n cross n is the side length of the square or the rectangle of the image. Now, assume that for each pixel, we have 3 channels, and on each channel layer, we have one value. That value usually ranges from 0 to 255. So that's an 8-bit image, unsigned 8-bit image. Now, assuming that we have RGB, we have 3 channels, but often now when we are working with medical images, or say astronomical images, we have more number of channels. So that domain is called hyperspectral domain. Computer vision works in both of these domains. One of the most popular and most popular breakthroughs in the field of computer vision is convolutional neural networks, which also has applications in NLP. Like recently, it was proposed that CNNs could be used to reduce the error by up to 10% on the time and phone recognition system. Next, we will talk a little bit about GANs and diffusion networks. These are a little bit more advanced forms of the models which we see every day in computer vision. So GANs are generative adversarial networks, which have proved to be immensely useful in producing synthetic data. And this synthetic data can be useful when you are defending against various types of attacks. For example, imagine you have a machine learning system and you want to see if It's susceptible to any form of attack like pixel-based attacks, etc., etc. And also it's useful for fighting AI bias. For example, imagine that you have a particular set of people which was used to train a model. Imagine that all of these people are from the North American demographic. But assuming that you would be deploying the model all over the world, the model might have a particular shift in its behavior when it moves to demographics of Asian countries or say, Australian countries, etc. To prevent those, we can actually generate faces of people or synthetic data which would complement our initial training and make our model more robust. Lastly, diffusion networks have just broken the state of the art on for GANs on image synthesis. It has already broken the state of the art on smaller datasets, and it's on the verge of doing that for larger datasets. This paper itself was just just came out in June 1st of this month. So, if any of you are interested, you can definitely go and look it up after the workshop. Uh, Now I would like to go and go to the next slide, which discusses classification. So classification is one of the techniques used in machine learning along with regression. So assume that you have some x values and you have a y coordinate. So we'll call our y label, we'll call our y value as the label value, and we'll call our x values as the inputs. So assume that we want to predict the price of a house. And now this prediction can be output in various ways based on certain number of inputs. Let's say we have the length of the house and the breadth of the house. These features independently are not very useful in predicting the price of a house because we can have a house that is say 500 meters long but 1 centimeter wide. That house would not be worth a lot of money. Similarly, the same goes for width of the house as well. But on multiplying the two together, we can generate a new feature called area, and area would definitely be useful in in predicting the price of a house because the larger the area, the more costlier it will be. Now we might also have a lot of features in a data set which are not very useful, which we can drop. So that is all part of the data cleaning process. These can include features like number of light switches in the house or the number of bulbs in the house, etc. These might be proxies for the price of the house, but are usually not very robust or relevant. So we would choose to drop these features based on certain statistical analysis, but at least for the price of the house, this can be intuitively understood that the number of light switches would not have a significant impact on the price of the house. Now, I discussed regression and classification. Let's take this example of the house price prediction and see if it's a regression problem or if it's a classification problem or can it be both. So if I'm predicting the price of the house on a continuous scale of output, for example, it can be 2 lakhs, 2 lakh 10,000, 2 lakh 15,000, it can be any numerical value, that would be an example of a regression problem. But assume that I'm trying to divide or predict the price of the house into buckets, separate buckets. Each bucket, for example, will have houses under rupees 1 lakh, houses in a price of 1 lakh to 2 lakhs, 2 lakhs or 3 lakhs. All the houses will usually be costing you a lot more than 1 or 2 lakhs. But for the sake of this example, let's assume that we have 5 buckets: 1 lakh, 2 lakhs, 3 lakhs, 4 lakhs, and 5 lakhs. In in these buckets, we can now put our houses, and then we'll have 5 classes. Now we can also have something called multi. So this example which I just shared was an example of multi-class classification. Now it can also be multi-class, multi-label classification. Imagine that you have taken a few pictures in the zoo, and so for example, we have the picture of a lion here. So we have data sets, for example, ImageNet and Coco data sets, etc., which are made by various companies like Google and Microsoft. What they have done is they have taken various objects and they have taken like 10,000 or up to 50,000 labels per image. I'm sorry, 50,000 classes of objects and that many millions of images per label, and they have trained these models on their data sets. So coming back to the concept of multi-class, multi-label classification, an object can be both a lion, a wildlife, and a mammal at the same time. So if you're training one of these models on your data set, it will actually not give you just the top first prediction. It will give you all the probabilities for each of the individual classes. So if there are 10 classes, you will get your output as 10 probabilities. If you have 100, you will get 100 output probabilities. So what we can do from here is that we can analyze the top K classification. So say only the first classification is lion. It is also a wildlife and a mammal. So for example, maybe the probability of it being a lion would be 93%. It being wildlife would be 4%. Mammal would be 2%. So by then we have covered about, I believe I messed up my math there, but 93, then 96, 97, 98. All right, so we have 2% remaining. And in that 2% would be the summation of all the class probabilities for all the other labels. So we can have top 1, top 3, top 5 classification, etc. And that's what is multi-class, multi-label classification. Okay. Yeah. All right. So the next interesting thing which we are going to see here is style transfer. Style transfer, as I understand it, is if you are having an image or a speech or any information and you are expressing it in another style, that would be an example of style transfer. Now, this information can be in the form of an image, it can be in the form of text or audio or anything whatsoever. So, in the first example, we see the image of a tortoise, and the second is Picasso's painting style. And gradually, we see that as the number of iterations increases, or as the model learns the style more and more, the the model is drawing the image of the tortoise in the style of Picasso. Similarly, we can also have some applications of style transfer in machine translation, code translation, for example, Java to Python, etc. Although style transfer is not very frequently used in those domains compared to sequence to sequence domains, which are, as Mohit mentioned, are more frequent in those domain areas. Next, we have an example of a whale sound on the bottom part of your screen. So let's consider the first waveform which you see there to be from the whale 1, the second waveform to be from the whale 2. So the third waveform is actually produced by taking the information from whale 1's audio form and taking the sign from whale 2's audio form. So that shows us how vast the applications of style transfer in the field of machine learning are. Now I request Mohit to discuss more about the applications of AI for social good.
Awesome. Thank you, Aditya, for the sharing your thoughts on computer vision. Now, this is something which has recently come up. AI for social good has been really talked about in last 5 to 6 years, and personally, this is my favorite field to work in the domain of AI and ML. Why do I say so? So AI for social good actually broadly uses AI and ML techniques to tackle some of the world's toughest challenges. And these challenges are real world problems that are faced across the globe. In this, we include a set of methods and mechanisms and tools that address contextual problems that are critical for a region of interest. These problems differ from solutions in other regions, and the proposed ML solutions effectively addresses these differences. So, what do I mean by this definition? So, let's just take a good example of natural disaster prediction. This comes under AI for social good. So, let us say that we want to predict whether there's going to be a flood in the next 6 months or so. So how do we do that? Now, this is a really tough challenge, and it's a real world problem which is faced across the globe. So we have the first criteria ticked over here, that this is a problem of relevant interest. Second, now we want to know about whether this problem is contextual in particular region. Yes, it is, because rivers differ from region to region. There can be rivers in the mountainous regions, there can be rivers in the plain regions, and there can be rivers near the ocean part, near the basins. So we need to come up with some machine learning or AI based technique that can satisfy these that can address the problems in these different regions, and also come up with measurable outcomes. So talking about the natural disaster prediction example that I'm talking about, the flood prediction thing, so the screenshot that you see here is from Google AI. So you might have come across this through Google, where they predict what would be the level of water at a particular time in a particular river. So how do they do that? The idea behind this is pretty simple. They use something called gauge metric, which is widely used in the field of fluid dynamics. They use this to measure the level of water that is there in the river, and then using concepts from physics, they feed these information to a particular machine learning model, and which predicts the level of water in at a particular period of time. So this is something that is very valuable to society, because this can prevent people from major disasters. Similarly, we have prediction models for tornadoes. Similarly, we have prediction models for forest fires, etc. So you can always check out these cool apps that are being made under the umbrella of AI for social good. Secondly, you must have come across many applications which use AI for health. This is a major field for research as well as for industry. AI for health has boomed a lot in last 5 to 6 years, and especially during this pandemic. So the aim behind AI for health is simple. If How can we use machine learning or AI based techniques to predict diseases through symptoms, or can we eliminate the use of doctor itself, although it might not be fair for me to say that, but there are regions, say a remote part in some X country in the world, where you don't have availability for doctors. So for through these models and through these applications, you can provide world class healthcare to people living where there are no facilities for doctors or good hospitals. So these models actually work on that principle. They detect diseases through early symptoms. They also predict various other parameters based on the input you feed. Third is something called improving accessibility. So AI for social good has been really proactive in improving the accessibility part. So what do we mean by accessibility? So people with who are specially able, we want them to come up at the same level as others, and through machine learning techniques and through other and with the help of robotics, we can actually provide assistance to them. So VWalk is something, a project like that. It is actually really this has been really beneficial for people with facing with visual challenges. So what is this project? This is nothing but a stick which is smart enough to tell its user where the objects are, what all objects are being what all objects are there in the surrounding, say in a periphery of 2 to 3 meters, and it also guides the person to take the optimum path. So this has been developed by Microsoft AI and VWalk. And yeah, AI for social good has been truly a game changer, especially when it comes to real world problems. And this is that's why this is personally my favorite field to work on and create an impact. So with that, we have come to the end of this section, where we discuss various subdomains of AI and ML and how we can get started with that. After that, I'll probably invite Hashim to speak about the future avenues and then probably we can just have a good discussion about our journeys, and probably we can answer some questions. And yeah, thank you.
Thank you, Mohit. Thank you, Aditya. This was very informative and enriching. I really appreciate your insights. With respect to where we see, I guess we already covered where the current implementations or the current applications of AI and how diverse they will be, or they are actually currently. The future of AI I actually see is, three things that I actually would like to talk about. First is to address the issue of bias in AI. So actually, there was an interesting study that came out in the AI Index, the Stanford AI Index 2021, that shows that speech recognition systems, for example, are not very adept or not very good at recognizing, for example, the voices or the speech of certain minorities. And that gives you a sense, based on the availability of data, maybe intentional or unintentional, the data that's being collected is not representative of the different people who would speak, even if you talk about certain dialects or you talk about country. That being example would be in the US, because that's where the majority of the data is being collected. So addressing the issue of representative AI systems or representative AI models, and you see that, for example, using AI for screening applicants in HR and hiring and recruiting. You look at, for example, certain names or certain degrees or certain language that is being put into a resume that may bias the decision making of a certain AI system. The second future to see is what we like to call multimodal AI systems, multimodal applications. As an example, that some of the things Mohit and Aditya, you guys covered, is you show how NLP, and there's NLP, there's computer vision, there is forecasting or personalization, recommendation. But really, the future is going to be where there will be a combination of systems that are actually part of a machine learning workflow. We quoted an example of the dubbing system, which involves speech recognition, machine translation, text to speech. But now even we're seeing people like, oh, I need to understand a document, but I only have it in my phone. So I need to run an optical character recognition and then connect it to an intelligent NLP for understanding a document. So figuring out opportunities to efficiently combine, and that's where actually there's an environmental impact to it, is to be able to, larger is not always better. We've heard now GPT-3 and large language models, and China just released a 1.75 trillion parameter model that actually is like beating the GPT-3. Larger is not always better, because when it comes to the practical elements of implementation, that's going to be a different story. Not everybody can afford to train a GPT-3 model and run it on an edge device, on a sensor or a phone or a camera or something like that. So obviously, being cautious and being aware of the environmental impacts of, or basically the footprint, computational and environmental impact of AI, and how to make them more efficient, is going to be very, very critical. And we're seeing right now different sort of image compression algorithms. We're starting to see distilled version or compressed versions of large language models that are still able to achieve efficient question answering, or still able to achieve summarization or natural language generation. The third thing,
Yeah, I would just I'd like to add this, what Hashim has already talked about. So since I've been working in industry for almost a year, I can totally relate with Hashim on this, that the larger is not always the greater thing, because in industry you need to be really time efficient. You need to have the results ready in milliseconds. So you need to get that information in a really distilled manner. And uh, I'll be frank that most of the machine learning applications that are being developed by big companies are really basic in nature, because the time constraint is such that you need to deliver the information as soon as possible. So that's why many of the techniques that are used are really basic in nature. And and you can easily code them down on your laptop too. So that's really exciting, that even whatever you are learning is actually being applied in the industry in real time.
Oh, absolutely, Mohit. And it's actually not just the customization or development. There's even existing pre-trained models right now that are being taken and customized. And actually, this is one of the reasons why we started Explain, is we realized you don't have to invent the wheel from scratch. You can take an existing framework, an existing pre-trained model, and plug it in into your overarching or into your sort of bigger AI solution. And obviously there's always a kind of like a balance, between, if you want high precision or high recall or high accuracy versus you want something that runs very quickly, and you say, well, I'm okay with losing a few percentage points in the accuracy, but I need something instantaneous to be run, especially when you're having a distributed edge of nodes or networks that are actually collecting data and you're running that in real time. And obviously, applications of AI are being more and more real time. Real time inference is being generated, and obviously, nobody likes to pay massive computational loads of GPUs and data centers in the cloud, because some people, AI, as it's being moved away from the large enterprises to go to small and medium enterprises and going to startups, a lot of them are actually trying to find and this is the exciting thing that's happening, is AI is no longer perceived to be this enterprise legacy software like ERPs in this past. Any startup that actually can start from the boot, from just the from the ground, can actually implement AI from the get-go. Even just actually today, you're a mom and pop e-commerce store, you can run a conversational AI to do customer support through a chatbot. It's impressive that now, but I mean, this is something that's right now we're seeing this kind of, what I don't know if I should call it AI 2.0, but it's kind of a sense that, okay, the technologies have been developed, now let's make them accessible. And I
Yeah, yeah,
actually,
I totally agree with that. Like, it reminds me of my internship project. So we worked on this cool project called QNAmaker.ai during my internship at Microsoft. So the idea was similar to what Hashim already told. We wanted the other companies and other startups to create their own chatbot in under 5 minutes. So what we made was that, hey, you just need to upload a text file containing your questions and answer, and we will make a chatbot for you. So this is something that Hashim already talked about, that improving the accessibility part of AI and ML, so that anyone who even doesn't know to how to code can actually leverage the technologies which are being used in the industry. So
uh,
yeah.
absolutely. And I mean, I'd love to hear from Aditya. I guess just because we're running out of time, we're running close to short of time,
Yes.
so I'd love to hear Aditya.
Thank you so much, Hashim, for the opportunity. Hashim mentioned about the various applications of AI, which the various applications of AI on the edge and the computational costs, and Mohit mentioned the time complexities of the algorithms and how that plays an important role as well, because algorithms have to run quickly. So nowadays we have basically divided it into two parts, kind of like one part is everything running on the edge, which is edge computation. The other school of thought would be everything running on the cloud and you making an API call, so that would be cloud computation. So advances are being made on both of the domains, and we are also having AI applications which have some parts of one model running on your device, which is an edge model. And if you have internet connectivity, it will actually pass the query to the cloud, and that would be the cloud model giving you a much better and more efficient solution. We also have seen massive improvements in the health sector, be it in COVID, which we see all around us, research about it, uh, cases analysis, data science analysis, etc. We also see machine learning playing an important role in lesser heard of or lesser spoken about diseases, like, for example, tuberculosis, which is one of the greatest and fatal diseases of all time, even more than COVID. So tuberculosis has been a lot of research has been done in the field of tuberculosis as well. So AI is also used in game theory and game playing algorithms, as Mohit pointed out. So overall, I can summarize that machine learning has been transformative in various applications all around us, and I'm really excited to see what the future holds for us. I'd love Hashim and Mohit to share a few final thoughts on this topic.
Yeah, I just remembered that probably we also wanted to touch upon how to get started with research in machine learning. So, as a student, so this is something like I'll be candid about this. So, me and Aditya were having a conversation last night about this. So, we were telling each other about our journey, how we started. So, we both started doing research in ML and AI. In our during our undergrads, and that's how we got actually interested in machine learning. So this is something that we wanted to share with everyone, that how can you get started with research, how can you work with cutting edge technology right here. So probably I'll ask Aditya to just share his research journey, how he got started.
All right, so it's actually a very long story, but I'll try to compress it into a 1 minute story. So I basically did not actually think of doing research when I was in class 11 or 12. I had basically made an algorithm which was very interesting for me. I just did it for fun, worked for 4 days continuously, almost 24 hours a day, and developed an algorithm which could play tic-tac-toe. So all the current approaches use an algorithm called Minimax, but my approach used decision trees, and it was later proven that it was 23,000 times faster than existing Minimax-based approaches, with the added advantage of it being randomized. So it makes different moves in the same board position and still wins the game every time. So now, come fast forward to my first year, I realized that I would like to write a paper about this, but I had absolutely no idea and no proper guidance, I would say, from faculties in my college as well, because research is not very commonly spread. It's not commonly accepted amongst undergraduate students, to be honest, currently in the country. So I wanted to start a team called Cognitive Applications Research Lab with the sole intention of making research more accessible to undergraduate students. We did a little bit about that, and I believe the greatest push for the lab and for my career as well was me winning Research Day in my second year. So after that happened, we quickly moved on to uh, publishing a few conference papers. Still, now my first journal paper was still under process. It took a lot of time and it is very hard. There are a lot of rejections on the way. But my first journal paper was published in IT Cognitive Computational Systems, and that's how I would say my research career started. After that, I did not focus much more on journal publications because journal publications are actually much more wordy but take a lot of time and effort as well. On the other hand, I try to devote my time more towards developing applications and deploying it and writing a paper about that. So as to make the applications more easily known. For example, I have a lot of applications in edge computing, TinyML, which have been like shared on LinkedIn and other social medias by Edge Impulse, which is basically a company which makes these boards as well, the edge computing boards, and the software for the same is also written by Edge Impulse. So all of these applications I wanted to disseminate or spread to the public in a much quicker fashion. So I choose conferences. I believe Mohit has a brilliant research career with a lot of journal publications, and he can share a bit about his journey and how the differences are and how he made the best out of the situation as well.
Absolutely. So I just keep it very quick. So how I got started, I started my research journey after my second year during my summer breaks, and I started with theoretical machine learning because I was really interested about how these algorithms work, and how I can make my own algorithm. And then it's been like 4 years since I've been doing research. I am particularly interested about NLP, but I won't talk much about my journey. Probably you can have a look at my LinkedIn profile and other stuff. You can find that out. But I would like to stress upon how you can get started. So, see, research can be really daunting. Looking at research can be really daunting at first, because reading research papers might look really. You might be really terrified after seeing a 11-page research paper to read. So, the best way to get started with research is to start developing a habit of reading papers, and then probably trying to apply whatever concepts have been told in the paper. So like I used to do this initially, that I used to, whenever I used to read a paper, I used to read it, say, in 3 weeks or so, slowly. And then I used to implement whatever algorithms or whatever models have been talked about in that paper. So that gave me a really good foundation on practical purposes, how I can translate their ideas into my code. And that also gave me some really good insights into how machine learning actually works. So this is something that is really a crux of research, doing good research, that you should be able to devote time and try to understand whatever is there in research papers, and not actually just passively reading papers there. And yeah, if you want to know more, you can connect with me, Aditya, or Hashem on LinkedIn and other social media platform, and we would be really happy to help you. And yeah, I guess we have something else also lined up there, Kunjan, right? Or we can take some questions.
We can just discuss the project first by Dibyasum. After that, we'll continue with the question and answers.
Sure. Awesome.
So, sir, it was really happy to hear about this technology and get to know more about this. I am very sure that our audience learned a lot from you people, and they will definitely enroll themselves for the courses you mentioned. So now, for making this session more interesting, I would like to call Debasam to showcase his project on ML. So, sir, stage is all yours.
Okay, thank you. So, hello everyone, and it was really an insightful session for me till now. I got to learn a lot about this market in AI, the future, the different aspects of AI, different domains, and here's my project which focuses on a subset of those domains. So let me share my screen here. Um, so I hope my screen is visible. Yeah, it's added. So so this is a project. Let me just give you a gist about what it does. This is a workflow chart which I built during our demonstration. Basically, the project is all about. Just imagine that right now we have this online education going on, right? And what do the teachers do to teach you? They open up the presentations, and it's actually not their fault. It's actually the lack of proper tool. So how are we taught during online education? We have our teachers bring up the presentation, they explain us the concepts, the best, and we try to understand, right? But there's a problem. It could have been more interactive, like for example in a physical face-to-face session, where you can look at what the teacher is trying to tell you. You can the teacher can draw inscriptions on the board and teach you the concept. So how do we imitate that thing and provide that kind of interactive sessions in an online mode? So I built a project around that, and this is not something that is ready for production. It was something that I started with a hackathon and have been working on it, and here's the prototype. So basically this is the deployment diagram. First of all, I'll show you the project itself, and I guess I have a working video of it. I'll share it in the screen. Sorry about that. Yeah. So this here, as you can see, as the this is the deployed diagram of this is the deployed functioning of the model. As you can see, this here is running inside Google Chrome, and the entire project is built on top of TensorFlow JS, which is actually a JavaScript variant of TensorFlow. I chose JavaScript because my entire backend, and to be honest, I am for backend technology, I normally use Node.js. Django would have been better, but since my tech stack was Node.js, so I stick to TensorFlow JS. And what it does is it parallelly processes two streams. On the left-hand side, you can see my webcam stream that is fetched from my webcam and displays as it is. with some modifications. As you can see, there is a green dot and a red dot here. Coming to that in a while. And on the right hand, and in the middle, you can see a black screen. Well, that is a blackboard. This is what can allow empower teachers to make online education even more interactive. So what it basically allows the teachers to do is, now instead of just opening up presentations on talking about it or explaining it, they can take up their pens and move the pen in front of the webcam, and the webcam, with the help of TensorFlow.js, will be traced, and obviously computer vision. TensorFlow.js is the execution environment. So with help of computer vision powered by TensorFlow, it will be tracing that hand movement, and that particular the model is actually trained to trace the hand in real time, and this comes under object detection. So what it does is it traces the exact location of the hand and jots that down into a blank image, and that then this image, which you can see in the center, is actually streamed back to the data, streamed back to the front end. So this is the data that I'm streaming. It takes input as that. This is the input that you can see on the left hand side. It goes to the server, and there TensorFlow JavaScript runs its TensorFlow JS runs its prediction. The model that I'm using here is MobileNet V2 SSD. SSD here stands for single shot detection, and then it traces that into the frame, draws that into the frame, and sends that frame back to the front end. And this frame is then streamed across all the people who are attending the meeting. So I'll just give you a small, brief about what data set I've used and how it works. So there's a data set which you can Google out. It's called Ego Hands. And it's an interesting data set. What it has around 4,800 images of hands in different backgrounds, and in different views and different backgrounds. You can see there are lots of images of hands in here from egocentric positions, and hence the name Ego Hands. So what it does is, this data, as you can see, this data was fed into the model, and the model at the beginning has no idea what it is being trained for. And once it learns through the data set, it gets the ground truths. Ground truth means the actual data that is fed, the real object that we are trying to trace. And then it tries to generalize that and learn over time. So you might be thinking how it actually learns. I'll just be as quick as possible to explain you that. And this was a very long script of how the model is actually trained. Well, I've already gone ahead and done that. I use Google Colab for training because it provides you a GPU environment, and to be honest, machine learning works substantially better in a GPU environment because it requires that parallel computing for processing matrices. And the only thing that I want to show you here is, in the beginning, you can see that the loss of the model, loss is basically how far it is from the actual ground truth. So you can see in the beginning, it was around 2.241 something. And I'll just skip ahead to 6 hours ahead from this. And after 6 hours, once the model was trained around 7,500 steps, you can see the loss became 0.03. And what it basically means is, right now, the model is not very accurate. It means as compared to its starting time 6 hours ago, right now it is way more accurate than that. And after that, how it is useful is, once the model is trained, we download those data into weights. And you might be thinking why a loss is necessary and how you can think about loss in general. Just think about this example. This is how I understood how neural network trains and what it basically does. Also, in the meantime, I'll show you a graph of this, which is helps you to analyze your training data, like the data that I just showed. This is called loss, and something over loss, and something related to steps. Well, you can actually analyze that in a better way. This is how the data looks when portrayed into a graph. So you can see over time, the loss was somewhere over here around 2.2, and over time around 7.5k steps of training, it became close to 0.3 somewhere. So what this basically means is, you can think, let's say at your home, you must be having a ceiling fan, right? You must be having a fan. And to control the speed of the fan, you have a knob at your place, a regulator in your switchboard. And that regulator has only let's say five different speed, 5 different levels of speed. So as you turn that knob from 0 to 5, you can control the speed of your fan. But let's say none of those 5 levels of speed is satisfying your need. So you install a second regulator, a second knob. Now you have 5 multiplies by 5, 25 different possibilities that you can, for 25 different ways in which you can control that same speed, because minimum and maximum speed is still same. And let's say even this does not satisfy your needs. So you get 1 million knobs, something close to 1 million. You can just imagine any big number. You have lots of knobs now. And how do you keep track of what position that each knob should be so that you get your desired result? Well, there are different metrics for that, and that metrics allows you to generate this kind of loss. There are many different kinds of loss. Since this is an object detection program, the three metrics that this primarily uses is called, you know, um, the first one is classification loss, then there is localization loss, and then there is regularization loss. So I guess I can zoom in here a bit, and you can see localization loss basically means, since here I am trying to detect the frame in trying to detect the hand in the frame. So I guess I had the video playing here. So I'll now try to explain what localization loss basically means. You can see this is my hand right here. So on the basis of the trained data, it is trying to compare how much close this particular object is to the data on which it is trained, the ground truth. That localizing that object in the frame, finding its coordinates, that is called localization loss. Then there is classification loss, which basically tells if the object that is localized belongs to which class. Is it a hand, is it as a dog or cat or something? So these are different metrics, and how those metrics improve over time, that is what this graph shows you. And with that, all that being said, here's a working of the model. Well, actually, I've not yet deployed it because that is why I showed you this plan. This is how I'm planning to deploy it. I'm working on it. It's kind of built now. I have on the second revision, to make it more production environment ready. But that is a gist about it. It traces the hand in real time. I think I lost the video. Oh yeah, here it is. So basically traces the hand in real time and streams it to the backend, and all these backends are provisioned under different Docker containers, which allow you to make your machine learning scalable and make end-to-end data pipelines. Uh, the data pipeline here that I'm built using WebRTC, it allows you to stream data. As you can see on the left hand side, as I'm moving my hand, the data is being sent to the backend, and the machine learning in the backend is now tracing that pen, drawing that into this shade black colored screen, and streaming it back to the front end. So that is how this entire pipeline works. And I just think that this once functional, once it is production ready, can be helpful for a lot of people. For example, if you want to do this with different devices, like there are iPads, there are touch pads, there are graphic pads that allow you to write with precision on a board in a digital meeting. But those are expensive, and this is free because this only uses your existing web camera. And that is how I what that is the problem statement that I'm trying to minimize. So that's about the project. And this, as I said, uses TensorFlow JS for the machine learning environment, and the scalability is done by Docker. And this leverages over Google's infrastructure management tool, or also called Kubernetes. And that is how it makes it available on the internet. It runs inside a Kubernetes cluster, which is itself running on Google Kubernetes engine, and the data pipeline streams the data between front end and back end. So that is the pipeline of my model, and this is how the model itself works. So that's all from my side. I hope you found it interesting. I guess there are many
Yes, sir.
different events lined up. And yeah, thank you.
Yes, sir. Indeed, it was a great project. Definitely, audience gonna learn a lot from you, your project. So now, without any further delay, I would like to request Gunjan to read all the queries asked by our audience, so that our speaker can, like, they can address their questions. So Gunjan, please.
Okay, sure. Okay, so the first question is, sir, how to get research internships and how to do projects? And which course is useful for getting job in CSC AIML? Can we build AI like Jarvis? Anyone can
Okay.
answer this.
Yeah, so okay, so first let's talk about how to get research internships. So for getting research internships, there are two primary ways. One is you can email the professors you would like to work. This is a little bit harder way than the other. The other way is that you apply to a specific summer internships portal. So yeah, almost every good university has a summer internship program that they run, and they actually open up for applications for summer internships. I guess for good overseas universities, they usually open the portal around November or December, and you can apply on them. And they usually don't ask for anything other than your CV, and if you can have a recommendation letter from one of your professors, that would be really good. The second way is of emailing professors, but that is hard because they get a lot of emails, like hundreds of emails in a day. So it's the probability of getting a reply back from them is low. So these are primarily the two ways in which you can bag a research internship. Secondly, about what skills you need to develop to bag a machine learning based job. As we already covered, like as Divya Som already showed you a project, right? That was a pretty nice application of computer vision, and he actually developed a an app out of it. So something like that, yeah. I mean, develop your CV in such a way that you have got 3 to 4 machine learning based projects which are on your GitHub, which are and better if deployed. You should have a good understanding about the core concepts because those are asked in interviews. And yeah, you are good to go because and um, in India, particularly, machine learning roles also require you to be a good coder at good companies. So you need to brush up your coding skills. That is invariably for any SD job as well as for machine learning engineer jobs. That is one thing that is required. So coding, good machine learning projects, and a decent grip on fundamentals is just all you need to bag a really good job. Yeah. If any if Hashim or Aditya would like to add to this.
No, I believe Mohit covered the question to a good extent. I don't have anything.
So, shall I proceed with the next question?
Yes.
Okay. So, somebody is asking, which is the best course you have had in your time, so that a beginner can start with it.
I believe everyone starts with a different journey and embarks on a different journey. I started with Andrew G's machine learning course, and then I proceeded over to doing the deep learning specialization. Then I did the TensorFlow in practice specialization. I have never actually done the fast APIs course, though I have heard others saying that the course is very nice and useful. So I would not say that there is a single best course or something. I would also suggest not to wait for the perfect course which suits your requirements, but to do the first course which you can, finish it, understand it, finish it as fast as possible, do a project, move to the next course if you want to move to your next venture. I believe if Mohit or Hashem would like to add something. Yes.
I mean, I haven't taken, honestly, I haven't taken a single course on AI. I mean, there's lots of material. I mean, if you want to talk about general intros to AI, a lot of the venture capital firms, a lot of the kind of, yeah, between venture capital firms, between the AI companies like Amazon and Microsoft are publishing a lot of great primers in terms of what are the definitions and the capabilities of AI, the capabilities of AI. If we're talking about technical, then my experience for people, they've taken Andrew Ng's Intro to Machine Learning and Intro to Deep Learning courses. Those have been quite helpful. So I can't comment much on the technical education, but in terms of the business education, There's Andreessen Horowitz, Sequoia Capital, NFX, and I'm happy to get in touch with anybody and provide those in separately. But there's a lot of great primers on how to get in and understand the overarching concepts of AI and machine learning.
One thing I would like to add, which I forgot to mention in the previous answer, was that do not spend a fortune on learning AI, because nowadays a lot of organizations might be bringing out courses which will cost an arm and a leg, and would be promising groundbreaking results like you will get this XYZ salary in 3-4 months. Uh, I have not personally seen them to work that well, and there are a lot of clauses, so do not fall for such traps. Personally, I have never spent a single rupee in my career of, at least in learning AI. There are a lot of free resources. I do understand that when you are doing a particular pathway based course, which would cost you a little bit higher, it would make your journey a little bit easier because you don't actually have to go and find the various resources. But personally, finding the various resources, comparing them, understanding them, implementing them has actually made me a better practitioner, I would believe as well.
Okay, great. So somebody is asking, what might be the sum of the exciting projects we should focus on? Okay, this is
All right, I believe I can take this question because in part of my research lab, computer applications research lab, or IEEE student branch, which I am currently heading the R&D division for, we see a lot of resumes, and we often see students who have first year students who just started doing machine learning a week back, and they have projects in GANs, they have projects in LSCMs here and there, stuff which would take even an experienced practitioner months to actually implement. So regarding the question of what's an exciting project, that's definitely a very personal question. For example, I personally find computer vision to be very exciting because of its visual implementation. I like the part of XAI where I can understand which parts of the neuron is lighting up to make which prediction. So that's exciting for me. I would suggest against going with the flow. For example, doing credit card fraud detection problem, Titanic data set problem. Great problems to start off, not good problems to write, not good AI solutions to write on your resume, because everyone has done this. Coming to the part which I am not sure which the intention of the questionnaire was, but regarding the word exciting, it should be personally exciting to you, but it need not be the state of the art in a machine learning problem when you are just starting off. You do not need to implement the latest scan or claim you have implemented it on your resume to get an internship or a job, because that might actually deteriorate your chances, because certain things appear to be too good to be true, and if you are not able to do good in your interview, because when you give a project of that merit on your resume, the interviewer will be having certain expectations. If you are unable to reach up to those level of expectations which you have raised, that would be a little difficult for you to actually end the job. You crack the job then for the truth.
okay. So somebody is asking, after the NSEM, they'll be having 45 days of vacation. So please suggest how to utilize those those holidays. Choosing if you want to learn AIML. So what should be the pathway to it?
um do Andrew NG scores. That's it. Like that's the most like the best advice anyone can give it to you. Like I haven't met a single person who hasn't started their AIML journey without Andrew NG scores. And even I started my journey with that course after my during my winter break. So this question actually reminds me of myself. And yeah, start with Andrew NG scores and start with some basic. As Hashim already has said, that there are various free resources available out there in terms of text materials. You don't even need to look for a book. You just need to find, say, if I want to learn about linear algebra matrix multiplication, just do a simple Google search. You will find a 5-page PDF. Read that and get done with that. You don't even need to read books. You just follow a good course like NUNG's course, and I guess you can finish it off in 45 days. And learn a good and get a good hold on machine learning. Yeah.
One
Okay,
important
so somebody
tip
is
I would give
asking,
about
how is AI and ML? Okay, okay, yeah.
I just wanted to add on to Mohit's answer where he mentioned enrolling schools, and I would just encourage the students to not give up in week 5, where the thing actually starts getting very complicated. So often students go up to week 5, and then when the math suddenly hits hard, students just think that okay, it's getting very difficult and give up. Do not do that. After week 5, week 6 is a little bit more harder, but week 7, 8, 9, 10, and 11 are much easier than that. And that's always there is a learning curve, right? And yeah, one more pointer which I would like to share is that definitely try to do the course in Python. I believe the course currently has an option in Python and MATLAB. Do not do it in MATLAB. At my time, I did not have that option, so I did it with MATLAB. But right now, you do have the option, and try to make a few mini projects as well in addition to the course, because that would give you a little bit of a confidence that you can develop the applications yourself. That's all from my side.
Okay. Next question is, how is AI and ML are useful and how they are affecting the market?
Yeah, I can answer that. So a lot of the major use cases for AI ML are obviously try to drive down the cost or increase. I mean, it's mostly saving time, reducing costs, or unlocking value from an existing product. The way we see it is anything that normally involves timely manual automation processes is something that is becomes an AI problem. And an example would be, for example, in industrial applications. Let's say I mean, we have an example right now. Look, for example, in warehouse workers or retail, where people have to do the counting for the inventory, and that's they done manually by people who have to stop the work they're doing and get in and spend a lot of time doing that. So if you develop a computer vision based system that can automatically reduce the complexity and run a scalable system so that you can actually free up the time of your critical workers to do other things. With respect to some of the examples that Aditya and Mohit have shared, machine translation, it's something that is available through an API, through a user interface, could cut down. We are seeing some of the reductions anywhere ranging from 50 to 75%. And so the ability to generate value through using AI systems. Some of them, obviously, the pre-trained ones that are readily available, they realize value right away. The other ones that you need to customize and build are more sort of for long-term value. And initially, the way AI gets developed is you define a certain limited scope for a proof of concept for a pilot, that you determine that this is going to be useful for a defined use case, and then you gradually expand that or you scale that sort of inside the organization. So healthcare predictive outcomes, especially for determining, I mean, I just like always to say healthcare because there's a lot of over treatment and over diagnosis. So determining which patient needs to be treated versus one that doesn't need to be treated, doing some matching based on your genetic profile or your protein profile to actually give you and personalize and prescribe the right drug for you is something that is also not only realizing for the cost reduction on the healthcare side, but also improving the patient outcomes, which is obviously part of the AI for good theme that sort of Mohit and Aditya covered. So these are just obviously, but you see it in telco, you see it in retail, you see it in different industry applications. So I hope that was just a kind of a quick overview and a flavor of how we're seeing the benefits. Gunjan, maybe next question if you have any.
Okay, so next question is, what's the difference between translation and chatbots?
So machine translation basically means you are trying to translate. So since it has a word called translation, It is basically translating tokens or words from one domain to the other. Now, these domains can be natural languages, these domain can be software languages, etc. It doesn't matter. So this is the essential fundamental idea behind machine translation. Chatbots, on the other hand, are more of a Q&A based system, a question and answer system, where the user enters their queries or their questions or whatever they want to interact with, and the machine tries to understand that concept and try to come up with the best possible answer that's available in its knowledge base. So yeah, that's the fundamental difference between chatbots and machine translation systems.
Okay,
Okay.
thank you so much, sir, for your insights. Actually, because of the shortage of time, we can't ask each and every question. We have shared the link of LinkedIn ID. You can directly ask to them. So now, I would like to request Saloni and Sanika for the Kahoot quiz, as we all were waiting about this moment. So, stage is all your audience. All the very best.
Let me know if my screen is visible or not.
Okay, guys, we are starting the quiz right now. So, are you excited? We have shared a link in the chat box. Kindly click on that link so that we can start the Kahoot game. So, guys, kindly click on that link and enter the pin so that we can start the Kahoot game. Here we got our first participant, second participant. Oh, they are increasing.
Join in, guys. I can see there are 60 people watching right now. Join in fast.
Guys, kindly come with your original name or your original username so that we can play that game in a smooth manner. It's a humble request. Link is in the chat box only. Okay, number is increasing. 15. Great. 16. Come on, guys.
Let's host
It
some
will be fun.
enthusiasm, guys. Join in fast.
Join ASAP, guys. It will be fun. The game pin is 2712658. Okay, 20.
27. Yes, it's increasing.
Yes, we will start game in a while. Till then, join. Okay, we are sharing the link once again. Join ASAP. Okay, 31. Great.
Guys, make sure that you are having two tabs or two devices with you so that it will be fine to answer the question.
34. Uh, Sanika, I think we should start the game when we will reach 240. What say?
Oh yeah, sure, sure. I think within 2 minutes we'll reach to 40 for sure.
Yes. Guys, join ASAP.
That is six. Yes,
Four more.
go for
Four
it.
more. Three more. Two more. Let's
Two
see
more
who
guys.
are these two. One more. One more. So who is that? Okay, 40th.
Yes, 40 average. Let's go.
Okay, shall we start? Yes, we should.
And starting the quiz, make sure that everyone is joined.
Yeah, be attentive, get ready, and let's get started.
Okay, so here is our first question.
The performance of an agent can be improved by the first option is learning, observing, perceiving, and none of the above mentioned.
Guys, you will see the options in your device. Kindly see the question here and answer accordingly.
You have 60 seconds to answer, so be fast. The
And
fastest
please
finger will be
don't
awarded
share
more points.
answer here in the chat box. You have to just click on the right option on your devices. Out of 40, 27, 28 answers. Okay, 30 more.
11 seconds still left, guys. Be quick.
So last 5 seconds. 5, 4, 3, 2, and 1. Okay, that's
The
great.
answer is learning. 24 responses are correct. Great. Cool, guys.
Let's see who's on. Okay, so 966 points. Let's move on to the
That's
next
really
question.
great.
What is the main task of a problem solving agent? Solve the given problem and reach to the goal to find out which sequence of action will get it to the goal state. All of the mentioned, none of the above. Go, guys, 50 seconds.
You are great to go, guys. Be quick. 20 seconds left.
Fast, guys, fast. Sanika, I think the answer is solve the given problem and reach the goal. What do you think?
Let's see. Let's.
Okay, so what's the answer?
Let's wait. Okay, so now
Oh,
Preeti is on the
Yes,
top.
Preeti
okay,
has
it
come
is on
over.
top.
Okay, great.
Guys,
Great.
where are my boys?
What is the action of task? Problem, solution, agent, none of the above.
Be quick, guys. Fastest finger will be awarded more points. Make sure that you see the first. 30 seconds left.
Okay, so last 20 seconds. Guys, fast, fast, fast.
Yes.
And yes, please don't answer in the chat box.
Yeah, you have to click on the correct answer there itself.
I hope you're enjoying the game. I'm just enjoying the game.
So
Okay,
the
so
answer
the
is
answer is
problem.
Oh,
okay.
again, Nuru has come over. Great, great.
Moving on. What is the goal of artificial intelligence? To solve real world problems, to solve artificial ones, to explain various sorts of intelligence, to extract scientific causes.
I can see that within 1 second, two responses are coming here. People are very quick, yeah.
Yeah.
People are answering very quick, really very quick.
I know,
So
right? They are very quick.
let's see who will win
20
this
seconds left, guys. It is getting very tough to compete, you know.
Yeah, absolutely. So last 10 seconds. Last 5 seconds. 3, 2, and 1. Okay, so who is in on top? Okay.
Great going, Nuru.
Okay, okay. So Muddu, congratulations. You are on top right now.
Web crawler is an example of intelligent agent, problem solving agent, simple reflex agent, model based agent. So already the answers are coming up 7, 8. Okay.
Let's see who is the first now.
You guys are quick.
20 seconds left, guys. Be quick. Oh, great. Again,
Okay,
Nuru has
again
came
Muddu is
over.
on top.
Congratulations.
Which of the factors affect the performance of learner system does not include representation scheme used, training scenario, type of feedback, good data structure. 40 seconds.
Let's see who will be the first this time.
So last 10 seconds. Guys, hurry up, hurry up. 39 answer. Great. Okay.
Oh, Modu has reserved his position on the first. Great, great.
Wow, there are new names. Yeah. General games involve single agent, multi agent, neither single nor multi agent, only single agent and multi agent. Hurry up.
Guys
Hurry
are
up, guys.
really
The
quick.
fastest finger, yes, yes. The fastest finger will be awarded more points. Make sure that you will be the first.
Okay, Sanika, to make this quiz more interesting, can you enable the music option? It will be great.
Okay, I will look into it.
Okay, so the answer is only single agent and multi agent. Let's see who all have answered. Again, Mudhu is on the top,
Okay,
and
Ashish is second.
Great
Dirshka.
going, Modu. Ashish and Discuss.
Moving on, the application or applications of artificial intelligence is or are expert systems, gaming, vision systems, all of the above.
Be quick, guys. 30 seconds left. As you can see, your questions are very basic. Like if you don't know AIML, it's okay.
Yes, and guys, please don't answer in the chat option. Kindly answer on the game only, on your devices only, please.
Okay, Mudu has reserved his position on the top. Let's see. So among the given options, which search algorithm requires less memory? First is optimal search, depth first search, breadth first search, and linear search. Responses are coming very fast. Great
Yes,
enthusiasm, guys.
absolutely.
Be quick, be quick. 15 seconds left. That's
Okay,
really cool.
Mudhu still on top. And five
Yes,
players have reached the answer streak 3. That's really, really great.
That's
yes,
amazing.
amazing.
10th question, the component of an expert system is knowledge base, inference engine, user interface, all of the above. Go, go, fast.
I can see within 2 seconds we have four answers.
Yes, that's absolutely great.
Great going, guys. 30 seconds left. Be quick. 20 seconds. Only three people are left. Please click the answer, guys. Six, five, four, three, two, and one. Let's see.
Oh, so the answer is all of the above. And Muthu is still
Again,
on
Modo
top.
is on the top. Yes.
I'm impressed,
Also, there's
Muthu.
a new name.
And Dilshad and Ashish, great guys.
An AI agent perceives and acts upon the environment using sensors, perceiver, actuators, or both A and C.
Kavita, you have
Be
to see
fast,
the
guys.
question on this that is displayed on the screen and have to answer what is in your screen.
Yes, on your screen, color boxes only will be appearing on your screen. Questions will be displayed on my screen only. So either you
Guys,
have
kindly
to,
don't answer here in the chat
yes,
Krishna,
box.
it is requested, just don't answer here.
either you will lose your point, nothing else. And your 10 seconds left. Great going. Four people left for answering the question. Three people. Two, three.
Might be you're choosing the wrong option, Mir. Okay, I can see the
Okay,
Shad is on a
Great
streak.
going. You can be on the top.
Which
So the
agent
next
deals with the happy, unhappy state? Utility based agent, model based agent, goal based agent, or the learning?
be quick. And your 20 seconds left. Great going, guys. Only four people are still remain to answer the question. Three people. 10 seconds left. Be quick. Great.
so
Oh,
who is still
great.
on the top?
That's
Muthu,
still
I'm
talking
impressed,
for me.
man.
Yes.
And Dilshad has a
With
streak with
8
eight
correct
correct
answers.
answer in the row.
Dilshad
Great,
is
man.
trying to
Great.
overcome. Great going. Try for more,
Dilshad, come
Dilshad.
on, you can do it.
It's a true or
Rational
false.
agent does the right things. True or false?
Dilshad, here you have a chance to compete with Modu. Let's see
Yes.
what happens with this question. Yes.
Oh, we are at the end of the quiz. Oh, that's so bad.
Yes.
I was actually enjoying the game.
I know, right? Okay. 25 seconds left. And only five people are still not responding to the question. Okay. Four, three. Well
Okay,
done, guys.
Shalu, you can't see the question. You can only see the options.
Okay. So the answer is true. And now let's see. I think, okay, Mudu is still on the top.
Yes.
Okay,
Dilshad
there
is
is a
second and
new
other
name.
Tiger. Yes.
There is a new name. Three in a row. Mehvish
Maywish
is
is
back
back.
in the game. Great, great. All the very best.
The next question
Which
is which
term?
term describes the more common sense of judgmental part of problem solving? Value based, critical, analytical, heuristic. This is the second last question, guys. It's the chance for the second and third positions to get on the first position. So be quick.
Okay, let's see. Muddu or someone
Yes,
else.
yes. I'm very curious about this now. You have 20 seconds left, 30 responses.
Sorry.
So the answer was heuristic. Let's see. And the
Okay.
third position is secured by Shubham. Great.
Congrats,
Okay.
Ashish. Like,
Muddu 10,000. That's really
Yes.
great. And
Maybe
Ashish
the
is
AI
making a
god or
comeback.
something.
And
Automatic
oh,
reasoning tool is used in personal computers, microcomputers, LISP machines, or all of the above.
so Roni,
This
what do
time I
you
can
think
see
about
oh,
six responses in 2 seconds.
yes, that's
Interesting.
absolutely great. And this is the last question. I'm really very, like, I was enjoying the game.
Yes. Let's see the final result, guys. It will be, I think it will be Mudu on the top. What say, Nimish?
I think. Let's
Okay,
see.
let's see. Yes.
Muddu, all the very best. And guys, let's see who are the top three in the game.
Okay, 9 seconds left. Six, five, four, three, two, and one. The time for the result.
Okay.
So here is the podium. The third position is
Oh,
secured by Shubham.
oh,
Great,
congrats, Shubham.
congratulations. The second position is Dilshad, and the first position is secured by Mudu. Yes,
Oh, congrats, guys. Massive congrats to all
congrats.
of you.
And runner-up Dazzle and Shreya. Congratulations to you too.
So,
Well
guys,
played,
don't
Mudu.
forget,
guys? The
yes, don't
feedback
forget
form is
to take the
shared in
screenshot.
the this feedback form is shared in the comment section. Just don't forget to click the screenshot of your screen. All the winners just click the screenshot, after then leave the screen. But once click the screenshot before leaving. Also submit the screenshot. Only then you will be getting the prizes and all.
Yes,
And for the
Great, guys.
absolutely.
certificate
Congratulations to all
and the
winners.
giveaways, you all have to fill the feedback form. Only the feedback form fillers will get the end
Correct.
products.
Okay. So, thank you so much, guys, for this amazing quiz.
Yes,
It
over
was
to you,
really
Nimish.
fun. So, now the result time for the first quiz. Uh, okay, so the first quiz, the winners of first quiz, drum rolls, and on the third we have Mahir for the first quiz, and on the second we have Sankirat, and first position. Okay, so the first position is by Abhishek Gupta. Guys, congratulations! A massive congrats to each and every person. So you just have to take this screenshot and attach with the feedback form which is shared. Guys, kindly fill the form for this for the certificates as well as the for the availing the benefits of for the winners. So in the last, I Nitish Mahajan would like to thank our sponsors, that are dot question mark, code for cause, AI explain, Taskade Repellent, and our technological partner Code in Campus, Codex, and then Girl Script Mumbai, Tech Ahead, IEEE, MSIT, IEEE, GTBIT, and also International Women in Tech. Media partner StreamYard, and certificate partner Give My Certificate. So without them, the event was not possible. And a thanks to our speaker also. So guys, kindly fill the form for the sake of certificates, and don't forget to add the screenshots.
Nitish, can
So
you share the feedback form link once again?
yes, I'm doing. Just a minute.
Guys, just don't forget to fill the feedback form. Your feedbacks are really important for us.
Okay, so we have shared the feedback form. Kindly fill the form and don't forget to attach the screenshots.
Also, the feedback forms will be open till 9:30. You have 1 hour to fill it. After that, it will be closed.
Yes, if you have any problem, then feel free to ask. And by this, I would like to thank to each and every audience which is there, and thank you so much.
Ashish, the PDF we'll share in the WhatsApp group itself. Okay, so by this we come to the end of the session. So thank you all. So here ends the broadcast. Screenshot is not for providing the attendance. Screenshot is for the certificates and all that you will be getting after the session.